Okay, so we've got another two-dimensional momentum problem here for a practice problem. This is the E1 problem in Unit 7, number 3.10. And we're talking about volleyball in this problem. We have a volleyball traveling perfectly horizontal over a volleyball net. Now, that's not very likely to happen in a game of volleyball, but let's just say it is in this instant. The ball is traveling perfectly horizontal over the net, and a player spikes it, and they drive this ball directly into the ground. It goes straight down. There's no angle. There's no funny business. The ball is just driven straight down, okay? Which does kind of mean that they had to reach over the net to do this, which I think is a violation in volleyball, but now we're getting into weird volleyball technicalities, so if you're into weird volleyball technicalities, this is not the channel for that. But we do know a few things here. We know the ball's mass, we know the speed before being hit, and we know the speed immediately after the spike. And what we want to figure out is, what is the impulse from the spike? So how much impulse or change in momentum did the spike give to the ball? So first thing that we should always do in a problem like this is to draw ourselves a picture. It's so important to give ourselves a picture. If we don't have a picture, we are going to be lost, okay? So let's draw a picture here. Let's go have the ball. So here's our net, right? So the ball is going to be traveling initially in this direction. So this is our initial momentum. And then after the ball has been struck, it's going to go straight down. It's going straight into the ground here. And this makes sense because if we have some player on the other side, flying through the air, that player is going to strike the ball in such a way that, they're going to hit it kind of this way, but that's going to negate the X momentum going to the right. They're going to cancel out. And then we're going to have a bunch of momentum just going down. So it makes sense in this scenario for the ball to come across the net and for that player to whack it back down at some sort of angle in the third quadrant, driving it straight into the ground. So if we redraw this picture, and redrawing pictures is so important, it really gives us an idea of a quick sketch. This is what should be happening. Let's redraw the picture to really get into the numbers of the problem. So if we redraw the picture, we're going to have a momentum going this way. And this momentum is going to be equal to a mass multiplied by velocity. We are going to have an impulse added to that original momentum, driving it this way. So that's the impulse that the striker, whoever's spiking this ball, is sending it at. And as a result of that, or a resultant vector, we are going to get some final momentum going down. So this is our resultant vector here in pink. It's a 90-degree triangle, which is very nice for us. And it's going directly down. And we can say that our second momentum here is a mass multiplied by a second velocity. So let's get these two momentums. And then since this is a nice right triangle, we can use a Pythagorean theorem with our two sides here, A and B, to solve for our hypotenuse, the impulse, which is side C. So let's go ahead and work through that. We know the mass of the volleyball in this problem is 0.22 kilograms. So our mass is 0.22, and the initial velocity is 6.4 meters per second, which gives us an initial momentum in black here of 0.22 times 6.4, which is 1.41 Newton seconds if we round that. And our final momentum going down is going to be 0.22, same mass of the volleyball, it hasn't changed, but a new velocity of 21 meters per second gives us a new momentum at the end of 4.62 Newton seconds. If we want to find this impulse, we are going to be using a Pythagorean theorem. If we recall, a squared plus b squared equals c squared, where our impulse is actually the hypotenuse here. So if we want to just solve this, we can say that our impulse squared, that's our hypotenuse, this is going to be equal to our two momentums squared, so 1.41 squared plus the 4.62 squared. And it's important to remember that if we want to get rid of the square on the impulse, we need to take the square root of this entire thing. And now it's just a matter for our calculator to get this. We want to be careful when we enter this into our calculator. It's very easy for us to make little math errors. I like to take it by steps. So 1.41 squared gives me 1.98 or 1.99. If I add that to 4.62 squared, I get 23.33. And then if I take the square root of 23.33, I get a final impulse here, J, of 4.83 Newton seconds. And that's it. That's all we are looking at for this problem here. If we wanted to, we could figure out what angle the person has struck this ball at from the horizontal. You know, we could find an angle here, some theta, by saying this is our opposite side and this is our adjacent side here. But we're not going to worry about that in this problem. We're just looking at what is the impulse generated by the striker whenever they hit that volleyball. And that 4.83 seconds is our final answer to this problem. The problem could also be extended by saying, you know, if their hand was in contact with the ball for some time, what's the force? And we could just say that, look, the impulse equals a force multiplied by time. That's a way to extend it. Or we could say that they hit the ball with some force. How quickly did that strike occur? And we'd solve for the time there. But for this, we are finished here. Wonderful problem in 2 dimensions. We'll see a little bit stuff similar to this as we continue on. But for right now, we're finished here. Adios, and take it easy.